Welcome, welcome back to our next session. It's about ultra-fast in-memory data processing with pure Java. Just a second, please. Let me share my screen. Here we go. So my name is Markus Kett. I'm CEO and co-founder of MicroStream, and now we are also proud contributors to project Helidon. I also am editor-in-chief for the JavaPro magazine and co-organizer of the JCon conference. And together with my team, we are working on Java since almost 20 years now, and most of the time we spend with developing Java developer tools. So we built 2 complete Java development environments, then migrated Swing development environment to Eclipse, and worked on the Eclipse tools for almost 10 years now. And during this time, we always thought about how can we improve database programming, how can we accelerate database programming, and how can we accelerate database applications through runtime. And so this is the reason why we worked on the JBoss Hibernate tools for Eclipse, and added additional functions and tools to the Eclipse development tools. And yeah, through this development, we thought, how can we improve the data storage in actually completely fundamentally. So not only to accelerate some frameworks and libraries, or some optimizing some configurations. So we thought about how can we improve data storage fundamentally to solve the core problems. And so we thought that with Java we have everything already. So with Java we have the best technology to build in-memory database applications, to be able to process all data in memory with pure Java. Why should we do that? Yeah, because we love object-oriented programming. We love objects. We love type safety. We love elegant object models. But as soon as we want to store data, then we have to use external database systems. And these database systems, they work completely different from Java, and they are not object-oriented. And we have to use query languages and database-specific query languages. And to use these database-specific query languages, we have to build Java query languages that generate the queries through the runtime. And so this is always it's always tricky and complicated to work with, and this is the reason why I believe database development is so effortful, and why our database applications through runtime are often so slow. With Java, we have already the perfect data structure. We have object graphs, so we can do everything with objects in memory. And with Streams API, we can query the objects or a complex object graph in memory in microseconds. And we have measured that we can query even huge object graphs, and even with huge memory sizes, it only takes microseconds. And in comparison to conventional database systems, then we talk about milliseconds. and which means searching an object graph in memory is up to 1,000 times faster, or it can be up to 1,000 times faster than a conventional database query. And so this means Java as a technology is really super fast. So why not using plain Java to build database applications? We also can use GraphQL and Lucene, and we have several libraries, various libraries and tools we can use in Java. We have the Azul JVM, we have native images to accelerate Java applications to get the max out of Java. The only thing missing in Java actually was always a native persistence. And this is the reason why we use external database systems. Or maybe in other words, the database systems, they were invented in the late 60s, and so they were already on the market when Java came on the market. So this obviously was the reason why we had to use the database systems. But now with the new SQL approaches, we are going to use different data structure, completely different models and approaches. And when we have a look on these approaches, then we see that they are also incompatible to Java object graphs. So we always have the same problems. And here on this slide, we can see an architecture of a Java app. It uses an object graph in the memory. And when we want to store data in a relational database, then the database uses tables and columns. So, and it's not possible to store complex object graphs in tables. We have impedance mismatches here. And to solve this problem, we have to use a mapping behind the scenes. With NoSQL, I mentioned it already, now the database vendors, they use completely different data structure. Some use key value, document, or graphs and objects. But even the graph and object models are not compatible to Java object graphs. So we also need a mapping here. And for the relational databases, we have the object relational mapping frameworks. And Hibernate here is the standard. And what actually mapping means is converting data behind the scenes. And through every single read and write, we have to convert data or have to generate code behind the scenes. And imagine if you have to convert a video, then it's always a latency, and it takes computing time for converting your video. And it's the same on a server when you access a database, and through every single read and write, the data have to be converted behind the scenes. So we have a latency here. And what is really astonishing is that even when we access directly to a local cache and read data directly from a cache, then it is not as fast as it should be. And because mostly the objects are serialized in the cache and has to be deserialized. So we also have a latency here. And mostly we have millisecond query time when we access directly to a cache. But actually, in-memory access should be microseconds or sometimes even nanoseconds. But it's not. And the reason is the object relational mapping. And the Wikipedia says, as long as the core problem exists, which means that the systems are completely different, sooner or later, all developers will get the same problems with performance, or your systems gets more and more complex. And this is the reason why we thought we cannot solve this problem. So we have to do it fundamentally different. And for the developers, we have always the same problem that we have to build our object model, our classes in Java, and additionally we have to build our data structure with the database systems. So we have to do it twice, double effort, and it's always a source of errors. With this system prevalence approach, we do it completely different. So with this approach, we use Java serialization to persist our object graph directly into plain files, and to use snapshots for persisting objects. And this was the previous concept of system prevalence. And actually, this is the simplest way to get persistence, or combination with persistence and transaction safety for your POJOs. And also Martin Fowler wrote an article, an interesting blog post about the system that bases on system prevalence, and he was very excited about the power of this system, and this was almost 10 years ago. But what's the problem with system prevalence? Because this is not much popular in practice out there. So there might be some challenges. And yes, there are many challenges with this initial concept of system prevalence. It's the snapshots. So the snapshots are mostly too big, and the snapshot time takes too long. And between the snapshots, you always can lose data. So this is always kind of like risk to lose data. And if you have big snapshots and you have to restore your object in the memory again after a system restart, for instance, then it takes too much time. So this concept will not work for microservices, because microservices, they have to start super fast in milliseconds. So this is not really suited for microservices. Then we are limited to the memory size. So your database system, your database cannot be bigger than your memory sizes. And when we use snapshots all the time, then there's a lot of traffic on the wire. Then huge memory sizes and Java, this might be a problem. So if you have not heard our keynote session, our previous session, then many Java developers think about garbage collector issues. With, for instance, a Zool, you can solve these problems. But this is often a topic. So garbage collector pauses, and then serialization itself is also could be a problem, because serialization is slow and has security issues. So there are many challenges, and this might be the reason why the concept of system prevalence is not that popular. But with MicroStream, we solved all these issues and built a game changer. And the MicroStream project started in 2013. And even 2 years later, we used it in production for the first time in a business critical project. And we were so successful, and it was so fast, so incredible fast, that we decided to build a project, to build a product based on MicroStream. And some years later, in 2019, we founded the company, and now we open sourced MicroStream. Yeah, you can now download MicroStream from GitHub, check it out, and fork it, and check out if MicroStream can help you. With MicroStream, we deliver not only a serialization. So what's in it? With MicroStream, you get a serialization that was written from scratch, which means MicroStream is not based on Java serialization. So it's really written from scratch. And on top of that, we have an implementation for the JVM, as well as an implementation for Android. And this is a persistence framework for the JVM and for Android. On top of this persistence framework, we provide a legacy, so-called legacy type mapping. So this always was with system prevalence, always was the problem. What happens if my classes change? So this was always a big problem. The same in object-oriented databases. With MicroStream, we have solved this problem. With legacy type mapping, it's possible to change classes all the time, at any time, and everything is handled by the engine behind the scenes. So we store the objects, mostly object references, appended to the file storage. So every single store is stored appended to the file storage, which means the storage will grow more and more. And to avoid that the storage grows more and more, we have added a kind of like garbage collector that works similar to the garbage collector of the JVM. And the MicroStream garbage collector removes the legacy types from your storage, from your files. Then we have a file system abstraction, and various database connectors that you are able to persist your object graphs not only in plain files. You also can use database systems to persist your objects. But be careful, at this point there is no mapping, so we store binaries, and so this is the reason why we can use almost all database systems to store objects with MicroStream. We provide a REST interface to access to the storage data, and on top of this REST interface, we provide a storage, a file storage browser. It's a graphical user interface you can use to browse through your storage data. And this is how the architecture looks like. MicroStream is only a small Java library you can download via Maven and include it into any Java project. It's only some megabyte size, and it runs within your within the JVM process of your app. And through runtime, we read the objects from the memory and serialize the objects into the file storage. But with MicroStream, you can decide if you want to serialize and store only single objects on object references, subgraphs, or collections. So you don't have to serialize the entire object graph. You only can store some single objects, lists, or subgraphs mostly. And here only the delta is stored. So only the data that are changed will be stored persistently on disk. And vice versa, you can load single object references and restore them in the memory anytime. So you don't have to load the entire object graph in the memory. And with these database connectors, we are able to use almost all database systems to persist the object graphs. There are no more mappings behind the scenes, no more data conversion. So data conversion are eliminated. And so this is the reason why MicroStream is that fast. And now we are able to query the object graphs directly in the memory. So different to database systems, we do not query the database system, the database server. We query the object graph directly in memory with Streams API or GraphQL. And this is the reason why searching with MicroStream is so incredibly fast. You have some database connectors, and MicroStream as a tiny Java library runs wherever a JVM runs. The only requirement is Java version 8. It also works perfectly with containers and also runs on GraalVM native images. You can use MicroStream with any JVM language, also on Android. So we have a small performance demo here on our website, and I mentioned it already today. This is a new version with Azul JVM. Here you can see there are two applications running in parallel. The first application is a bookstore demo. It's built with Hibernate and EHCache. So this is the same stack we have used in our development environment, Rapid Clips. We were working on 10 years, and so we have tried to improve these Hibernate tools. And here, this is the same stack we use in this bookstore demo. You can see the queries that are executed with Spring Data. And then we have an application running built with MicroStream. The data model is quite different because we have now, it's now possible to build a real life object model. So we don't have to care for tables and relations. So yeah, you can build your object model freely with MicroStream. And here we can see how fast MicroStream, or actually this is not MicroStream, it's we are querying the object graph in memory. So this is the performance of the JVM, and you can see the difference, and all the queries are executed up to 1,000 times faster. And this is the JVM power. So download the bookstore demo from GitHub. You can play around and try to make JPA faster. But I think with pure Java, Streams API, here Lucene is used in this project. Yeah, it's super fast. And so you also can accelerate your own applications. Nothing can beat Java, I would say. Yeah, play around and check it out. What are your benefits? So many people ask me, what can I do with performance? We have quite some ideas. You can build now things that were impossible some years ago. So think about AI, machine learning, or also, let's say, boring database application that have to deal with tons of data behind the scenes. CRM systems, ERP systems, everything that processes data, or sometimes only for storing some simple metadata. It depends on your use case. What else? With this incredible performance, you will save lots of CPU power. So think about if you have a huge cluster that must handle tons of data and huge workloads, then you will need lots of CPU power, and this will increase the cost of infrastructure. Here we have a simple example. It was a project at Allianz insurance company in Munich. So we have planned a traditional cluster, and today this application runs on only one single machine. It's high available, so actually 2 machines. But we were able to save up to 90% costs in the cloud for our customer. And this is possible with almost all database applications. And for you as a developer, of course, it's more convenient because now you only have to deal with POJOs. That's it. How does it work? Here we can see a small and simple class, a customer class. Here you can see no annotations. You don't have to implement any interfaces, and you don't have to use any superclasses. Just POJOs. You can design your object model freely. So you can now build real-life object models. You can use all Java types. You can use lists, collections. You can use any collection library you want to use. Yeah, be careful. Sometimes there will be some types that are not already supported by MicroStream, but most of the JDK types are already supported. Many collection libraries and third-party libraries are already supported. So if you have some issues with MicroStream, perhaps there it depends on some types that are not yet supported by MicroStream. Yeah, writing Java classes, POJOs is really super simple and convenient. And to store your objects, you only have to call one store method. And you have to call the store method on the object you want to persist. So for instance, let's say if you want to store an object in a collection, then you have to store the collection. So always the owner object has to be stored. And MicroStream cares for the rest. So it stores only the objects that are changed. So if you have a huge collection and you change only one single object, then only one object will be stored. And we store only the IDs. So if you have a huge collection and you change something, then only IDs will be stored, not the entire collection again and again. Here we can see a small animation. So when we call a store method, then we store the binary appended to the disk and appended to the file storage. So if you call a store method 100 times, you will store the object 100 times appended to your storage. This is not a problem because think about, we have this garbage collector, and the garbage collector will remove the legacy objects from your storage. So you can configure that, runs smoothly and stable. And you also can use channels for storing your objects, and it depends on how many cores your hardware supports. The more channels you can use, and so you can use all the I/O operations in parallel. How does loading objects work? When you start the application and initially, then MicroStream initially loads the entire object graph in a memory. But at this point, be careful. We only load the object IDs, not the objects. The objects are not loaded. Only the object IDs are loaded into the memory. So we have the entire object graph or all informations about the entire object graph in memory. But you as a developer, you can decide which objects, which data you want to load initially, and which objects you want to load on demand by using lazy loading. If you have enough memory, of course, then you can load the entire database into the memory. Then you have best possible performance. You can query your entire database in memory. This will be super fast, no latency. But on the other hand, startup time will increase. So perhaps this is not a good fit for microservices. So it always depends on the use case. If you have a huge database size, let's say 1 terabyte or so, or 10 terabytes, 100 terabytes, and you only have, let's say 16 gigabyte RAM, then just load the most important data initially in the memory, and all other data you can load on demand by using lazy loading. So this is suited if you have a huge database storage size, or if you build a microservice that has to start fast and loads data when needed. So this depends on the use case, but you can do both. This is very important to mention that with MicroStream you can keep the entire database in memory, but this is not mandatory. Memory management. So everything is managed by the JVM, of course. So we don't touch the objects in the memory. So everything is managed by the JVM. But you can influence your lazy references. All the lazy references can be cleared at any time to save memory, to save RAM. Yeah, we say that with Azure JVM, you can use also huge memory sizes without any garbage collector issues. Queries. So I mentioned it already with Streams API, you can query your object graph in microseconds. So it's really proven. It's a great API. It's type safe. You can use parallel streams to max your speed. So this is really powerful query language, and it's core Java. Yeah, this is funny. This is how our garbage collector works. Here we can see some legacy objects in our storage, and now I will activate my garbage collector, and now it removes the legacy objects from my storage. So this is how MicroStream works on the storage side. So you can configure it, the garbage collector. And once again, MicroStream is a paradigm shift in database programming. Here on the left side, we can see the traditional architecture of a database. Here we have a database server. You have your database on a remote machine, and you query the database on the remote machine. This is the database server concept. On the right side, we can see the MicroStream system prevalence approach. here we have only the storage data in a in a storage, and it can be a database system. It can be plain files. So there are only the storage data, and you have to query your data in memory. This is the big difference. So you have to load the data into the RAM and then query the data in memory. This is a different approach, and so you have to think about that. This works a little bit different, but it's plain Java, so everything is core Java. Nothing, no more new rules or no new query languages, no MicroStream specific concepts. This is plain Java. This is core Java, and this is really easy to use. The only thing is, honestly, you have to care for concurrency. Okay, so if anything is missing in Java, or I'm sorry, in MicroStream, then you can use almost everything that is available in Java. GraphQL, Lucene, for instance. Everything can be used very easily with MicroStream. MicroStream is open source, and we release MicroStream every 6 months, which means the next version 6 will come. Florian mentioned that perhaps we can launch MicroStream version 6 during the JCon. I don't know if this is we can do that, but the next few weeks we will launch MicroStream 6, and every 6 months we will launch a new version of MicroStream. Currently, we work on a distributed system that you can build distributed systems with MicroStream, and we work on a MicroStream cloud service. I also mentioned today already that MicroStream is also a high secure serialization. With MicroStream, it's not possible to inject and execute malicious code through deserialization. And this means that MicroStream is a high secure serialization. And if you want to transfer data highly secure, then you should check out MicroStream. Perhaps MicroStream can help you to build high secure systems. So now we have some time to have a look on the code, or do we have some questions? Okay, Florian, are you ready for browsing through some code?
Yeah, sure.
Okay, cool.
You have a few questions regarding concurrency. Basically, what I can say in short is if the concurrency depending on the storage isolation is what MicroStream can handle. On the object graph, MicroStream has no influence at all. So you have to take care of it by yourself with Java core tools like synchronization, reentrant logs, and stuff like that. And another question was if multiple JVMs access the same graph. That is technically not possible. You have one object graph, one heap per JVM. You can't span heaps over several JVMs. So that's not a problem at all, I guess, because it's not doable technically. So yeah, the legacy type mapping, the question if old data is accessed in a new version, that's what the legacy type mapping is for. and it's done on demand. So not the whole database will be rewritten if you update your code, but if records will be loaded from the storage which have an older version, the legacy type mapping will migrate your data on demand, and only if the new versions of the records are written again, then the new bytecode will be produced. And the housekeeping of MicroStream will delete the older legacy data from the storage, so you don't pollute your data storage. Yeah. Question is documentation with Lucene. It's what I wanted to show you anyway. Because a good starting point is our sample application, which is online at GitHub. Just let me find my browser window. Here we go. So on our GitHub site, you can either let's take a look at our bookstore demo. It's an application which shows how a MicroStream application can be structured and integrated with several other frameworks. It's based on Spring Boot. It uses a modern web user interface. It has a GraphQL layer inside, and it uses Lucene for full text storage. So you can combine basically every framework, any Java framework with MicroStream, and you can use the benefits of either side. So if you want to use full text search with pure Java, you can use regex or plain string comparisons, but it's not very quick. So we use Lucene for that in the bookstore demo, and Lucene index is stored again with MicroStream in a storage folder, so you can combine these two frameworks pretty well. And if you look at the code, you can see you can design your data model as plain POJOs. There is no need to annotate, to extend or implement anything from MicroStream. Just use your classes as they are. Use third-party classes in your code and connect it with the MicroStream storage manager, and you're good to go. And basically, all you need is calling store methods, and use lazy loading if you don't want to risk a memory overflow out of memory error. The lazy loading is described in detail in our documentation, of course, and I will show how you do lazy loading, how you do evolution of your data in my workshop on Friday. I will go into detail in this workshop. Okay, so another way, of course, is our documentation. There are several links to the repository as well, because in our main repository we have small examples. Legacy type mapping, custom type handler for special types, how you do different ways of storing data, batch processing, the layered entities which can be used for versioning, for example. It's all described in the documentation with cross links to our source code. So all right. MicroStream works with records. Yes, it does. It's basically yes. So there is maybe a switch you have to start the JVM with, because of the reflection is limited with records since Java 15, if I remember right. But it's doable. You just have to hand over a switch to the JVM, and MicroStream can work with records. MicroStream works with enums as well, and different other language constructs of the JVM. Yeah. Did I miss any questions? The changes of data structures, yeah, it's like I mentioned, the legacy type mapping. So you can evolve your classes throughout your application lifecycle, and MicroStream will cope mostly fully automatic. The heuristic catches most of the cases, the common cases. If you want to transfer data, to migrate data for special cases, you can provide, of course, a custom legacy type handler. And then you can pretty much evolve your data in any way you like. So you can extract super types, split your classes, rename, extract interfaces, refactor, whatever you do with the right custom legacy type handler. It can be done. Yeah. Why should I use database system to store MicroStream models? You don't have to use a database. Some customers wanted to use their licenses, which they already had, to use features of the database management system, like backups, stuff like that. If you don't need that, you can use, of course, a plain file storage, or use S3 at AWS, and basically every blob storage is supported. Yeah. The most common case, of course, are flat files and blob storages of the various cloud providers. Yeah. To be honest, I don't know much about the CQRS architecture. I will have to check it out, and maybe we can meet in a separate breakout room later on. The moderators will post a link for the breakout room after the session. Yeah.
Okay, no more questions. Then one last hint. Florian, can I share the screen? Yes. Thank you. I'd like you to invite to our MicroStream Summit in November. And here we will introduce use case. So real world use case with MicroStream. It will be a one-day online conference, and it will be free. So you can enroll for free. And all of you who wants to submit a session proposal, you can win $1,000 prize for all accepted submissions. So here you can enroll microstream.one/summit. Yeah. Then thank you very much for joining. Have a great day and have a great week at JCon. Thank you and goodbye. See you.